Okay, let's look at a problem that's a little bit more difficult. We have a white brass, which is our alloy, consists of 60% copper, 25% zinc, 15% nickel. How many grams of the alloy can be made from 1 kilogram of copper, 350 grams of zinc, and 200 grams of nickel? How many grams of each of the pure metal would be left? Okay, the first thing we need to understand is what's an alloy and what's the relationship in the alloy to all of the different metals. So we know that 100 grams of the alloy is going to be equal to 60 grams of the copper. We know that 100 grams of the alloy is going to be equal to 25 grams of zinc. And we also know that 100 grams of the alloy is going to be equal to 15 grams of the nickel. So the first thing that we need to be able to understand is what is the limiting reagent in this mixture? Which one of these metals would produce the least amount of the alloy, the white brass? So the way that we simply do this is we know from what we're giving and what the relationship from these equations here, from these equations, that how much of the alloy we will actually produce. So if we have, in this instance, we have 1 kilogram of copper, which is 1,000 grams of copper. If we have 1,000 grams of copper, how much alloy would it produce? Well, from our relationship, we know that for every 100 grams of the alloy, in this instance here, we have 60 grams of copper. So remember when we were doing our factor labeling method, the thing that we want to cancel out is always on the bottom, and whatever we want to produce is always going to be on the top, the numerator. So we have 60 grams of copper, which causes our grams of copper to cancel out, over 100 grams of our alloy. So if we do this, we will get 1,000 times 100 divided by 60 will give us 1,538 grams of our alloy. Do the same thing, we have 350 grams of nickel, 350 grams of zinc, 350 grams of zinc times 100 grams of our alloy divided by our 25 grams of zinc. Grams of zinc cancel out. We get 1,400 grams of the alloy. If we do our next one, we have 200 grams of nickel. Multiply this by our relationship. We know that for every 100 grams of alloy, we have 15 grams of nickel. Grams of nickel cancel out, and our answer is 1,333 grams of alloy. So this information tells us that the nickel is the limiting reagent. It produces the least amount of the alloy. So this here has to be our limiting reagent. So now, knowing this, we now have to take this information and relate it to the zinc and the copper. So if we have 1,300 grams of alloy, will produce how much zinc do I need in order to produce 1,300 grams of alloy? How much copper do I need to have in order to produce 1,333 grams of alloy? So what we have to do now is ask ourselves, how many grams of copper is equal to 1,333 grams of alloy? And again, we use our relationship from knowing that 60 grams of copper is equivalent to 100 grams of the alloy. Grams of alloy cancel out, and our answer is given to us as 799.8 grams. Now, so this is how much copper we would need in order to make 1,300 grams of alloy. We're told in the equation that we have 1,000 grams of copper. We only need 800 grams. So if you subtract 1,000 from 800, you will have 200 grams of copper remaining. So this is our excess. Let's do it again for the zinc. How many grams of zinc is equal to 1,333 grams of the alloy? Well, we know from our relationship that for every 25 grams of zinc, I have 100 grams of the alloy. Grams of the alloy cancel out. This gives me 333.25 grams of zinc. So I would need 333 grams of zinc in order to produce 1,333 grams of the alloy. We're told from the problem that we have 350 grams of zinc, but we only need 333 grams of zinc. So if we subtract 350 from 333, we will have 17 grams of zinc remaining. Okay, that's a wrap. That solves our problem.